using these principles, it can help you to put these things into perspective and enable you to remember it. And then it'll be anchored into your mind so that when you finally grasp the concept, now you have categorical boxes that you can put it in.
What's up, everybody? Today on Universal Theory, we're going to be talking about the double-slit experiment, everybody's favorite experiment that they've seen a million videos on, and this is why we were asking ourselves how we add value. And if you've seen the earlier video, you know how we add value is by combining the principles with science. And what I would like to do is challenge you. If you can find a video out there that talks about the double-slit experiment and applies the 7 Hermetic principles, or even just a couple of them like we are going to do, then I will Venmo you $20. I'll only do it for one video each, but that is how confident I am that no one else is doing this out here. So if you already are familiar with the double-slit experiment, there's going to be something here for you because of the content that we provide to YouTube. To everybody who's been in the comment section down below, we greatly appreciate you. We couldn't be doing this without you. The channel is growing like crazy. We very much appreciate it and know that we would not be here if it wasn't for everybody that's been sticking around and showing up every week and now every couple of days. So we really appreciate that. Moving on to the double-slit experiment. People say the double split experiment, and I might have said it too, and it's like, it's not what it is. There's 2 slits. That's why we call it the double slit, because there's 1 slit and then there's 2 slits. And that's why I said double slit. So the double slit experiment is essentially when scientists were like, oh crap, we have no idea what's going on here. You know what I mean? It was like, oh, we thought photons act as waves. Okay, cool. We're cool with that. And then, electrons do the same. Oh, protons. Oh, Buckey balls, which are like 20 carbon atoms strategically placed together, still create these wave functions. So we're like, whoa, we're moving out of the atomic into the into the molecular stage where we're still seeing wave functions. And a quick fun fact, we all have wave functions. Everything has a wave function. Just the larger that you get, the smaller the waves are, right? The smaller the wave of probability of where you're going to be kind of is. I'm not 100% sure. I remember how the math worked when I did the problem that my professor made us do. He made us find how large the wave function was for our bodies or something like that. So even though, when a wave function collapses, so it's not that kind of same wave function, but it's like the waviness of our body. Let me say it like that. That's a better way to say it. The waviness of our body. We all have a wave to us. Nothing is solid. We know this. Every 99.99999% empty space and nothing solid. It's all an illusion. The double slit experiment is essentially, like I said, it's what broke a lot of physicists' minds, and that's when these very heated debates came up about what's true and what isn't, and pilot theory came from this, the Everett interpretation came from this, the Copenhagen interpretation came from this, Bell's inequalities came from this, which are the hidden variables. So a lot of different aspects of science came from this, and we're still not 100% sure what's true. If you saw our last video, we did Copenhagen interpretation versus the Everett interpretation, and that's all they are, interpretations of the math. But essentially what's happening is when you have 2 slits and you send, we'll just use an electron. When you send an electron down it, if you don't measure which slit the electron goes through, it's like it knows that you're not going to measure it, and it will interfere with itself. And this is one misconception. People think that now it hits wherever it's measuring in some distribution. That's not what happens. But once you send 1,000 of them, so it hits in one spot, then the next one, the next one, the next one, they all hit in certain spots. And once you send 1,000 of them, if you haven't been measuring it, you'll see a bright spot, a dark spot, a bright spot, a dark spot, a bright spot, a dark spot, a bright spot, a dark spot. And that is the distribution. That is the interference pattern that these electrons are creating with themselves. As they're moving through, it's interfering with itself, and now it has a probability. It's a very high probabilities in the middle, less probabilities on the outsides, and less until, as it goes further out. So that's what's happening with the double slit experiment. And then what was mind blowing was when they measured one of the slits. So it's not measuring the electron before or after, it's knowing the path that it took. So if you put a measuring device on slit A, now you just have two. It's not like on slit A there's a bright spot, but then where slit B would be, there's this distribution. Nope. If you're measuring which one of the slits is coming through, it's like you're measuring both. And you only see two bright spots now, right behind the slits, exactly what you would think classically. So this brought in a whole new level of kind of randomness and probabilities, and people gave up on cause and effect. It's a principle that I am near and dear to, and me and you have had quite a few conversations about cause and effect in the quantum realm, and I'm like, no. Even if there was some sort of randomness on the quantum level, it wouldn't make its way through to the top. So yeah, that's the double slit experiment in essentially its totality. There are different modifications of it. At some point, we will talk about the quantum eraser experiment, which is a modification, a very intelligent modification, and actually it kind of is. It's very mind-blowing. I'm not going to get into it, but if you want to look it up and get ready for it, because that's coming.
So once again, I always like using the principles to try to ground it so that you have an anchor to go off of until you actually grasp the concept. And then when you do finally grasp the concept, because you have an anchor, you'll be able to recall it more easily as well and look at it from different angles and have an entirely different perspective than someone else who's not using the principles.
Oh, yeah.
Even though they're relevant to the topic, because they're principles, they're substantial, they're absolutes.
Yeah.
So, think of the particle as being masculine in a wave state. And when it collapses, well, that is a feminine state, because now it's matter, as we like to call it, matter.
Mother Nature.
Exactly, the mother. And then you could also think about the particle when it's not being observed. You could think about it being masculine, and then when it's observed, it's feminine. And, because once again, it's masculine in a wave state, it's feminine in a collapse state, or you can look at it the other way around if you want, because equal in nature, different in degree. You could also think about when someone's observing it, when they're observing it, they're projecting that energy vibration, they're projecting that energy onto that opposing pattern, and it's creating an interference. And the particle at that point, whether if it's in a wave state, well, it's being receptive like a womb. So it's being receptive to this masculine influence, and then that's what's causing the collapse. So even though in one sense it's masculine because it's a wave, if it's being observed, like I said, it could be a machine or it could be a person or whatever, but when it's being observed, then that observation is masculine, and it's causing that feminine to be receptive to that energetic influence, and it's causing it to collapse. So it's all about, masculine and feminine wave particle duality, observer, the thing being observed, and then the energy of the wave versus the collapse of the wave, or the energy of the observer versus the energy of the observed. So using these principles, it can help you to put these things into perspective and enable you to remember it, and then it'll be anchored into your mind so that when you finally grasp the concept, now you have categorical boxes that you can put it in so that you can more relate to the subject. And it's not like I'm fabricating these principles and saying, oh, this is just a good memoristic technique. It's actually allowing you to have a more in-depth perspective of the concept itself.
Yeah, it's holistic. It's a holistic way of seeing things. Even if you do just use it as a technique, at first that's fine, but it's going to start to activate that right side of your brain. When you're starting to use these principles, it's going to help you to kind of see outside the box, and then you'll start to you'll be using both now. You'll be using the left through the science and the right through the principles, and that's this holistic thinking that Jordan and I are preaching about, that Jordan and I are practicing, that Jordan and I are living by. And when Jordan was talking about, gender, it's one of those things where the absolute version of gender is androgynous, right? And that's why Jordan said you can say that this is masculine and this is feminine, and then this is feminine and this is masculine, depending on what system you're putting it in, how you're building the pieces, right? How you're putting the puzzle together. But it's important to understand that gender as an absolute is androgynous, which means that it exists as male and female at the same time.